A certain prescription medicine is supposed to contain an average of 250 parts per million ppm of a certain chemical. If the concentration is higher than this, the drug may cause harmful side effects. If it is lower, the drug may be ineffective. The manufacturer runs a check to see if the mean concentration in a large shipment conforms to the target level of 250 part per million or not. A simple random sample of 100 portions is tested, and the sample mean concentration is found to be 247 ppm, with a sample standard deviation of 12 ppm. This is essentially the hypothesis test problem with the initial claim that whether the mean concentration mu is meeting the target 250 or not. The test is about a claim about the population, and we pick a sample, in this case a sample of 100, so n equals 100, and we compute the statistics. The mean concentration from this sample is 247, so x bar equals 247. Also, the standard deviation from the sample is 12, so s equals 12. This is the hypothesis test for the mean, but with sigma not known. Sigma is unknown in this case. And so we will use the t-test. The first step is to state the hypothesis, the null, and the alternative hypothesis. Remember that the null hypothesis is a statement of indifference. To do this, we first write the initial claim and the opposites of the initial claim. The opposite of equal is not equal to, and so the opposite is mu not equal to 250. The expression without the equal sign is the opposite, and that will go to the alternative hypothesis. So the alternative hypothesis H sub A is mu not equal to 250. The null hypothesis, therefore, mu equal to 50. The null always have the equal sign. The only thing that we need to do here is to change the inequality from the alternative hypothesis to the equal sign and obtain the null hypothesis. This will be the two-tailed test because the alternative hypothesis indicates this is not equal to. We don't know whether it is the left or the right tail test, but with not equal to, it is the two-tailed test. The condition for the test is met because n is clearly greater than 30. We do not need to check the normality here because the sample size is greater than 30. Next, we compute the test statistic t. The test statistic t is x bar minus mu sub 0 divided by s over the square root of n because sigma is not known. X bar is 247. The null value is 250 divided by s. The standard deviation of the sample is 12 divided by the square root of n. The sample size is 100. Input this into a calculator. We will get negative 2.5. Because the t's value is negative, we indicate on the graph that the left hand side is negative 2.5, and we're looking for the error on the left hand side to obtain the p-value. But since this is the two-tailed test, the p-value is twice the probability of t on the left of negative 2.5. And if we use a calculator, we'll get 2 times 0.007 because the probability that t is less than negative 2.5 using the degree of freedom of 99, one less than the sample size. And so the p-value is 0.014. With Desmos.com, since this is a t-test, we're going to use the t-calculator. To use the t-calculator with Desmos, we type TDIST for the t-distribution, and we would need to specify the degree of freedom for the t-test. and the degree of freedom is 1 less than the sample size. The sample size is 100, so the degree of freedom is 99. Click on Find Cumulative Probability. We saw earlier that we shaded the error on the left-hand side, so there is no minimum value on the left. It is unbounded on the left, so we would leave the left at negative infinity, but the maximum is the test statistic that we compute, and it was negative 2.5. We get the p-value of 0.007, but this is only for the left tail. Since this is the two-tail test, we would need to double 0.007 to get 0.14. The next step and the final step is the conclusion. This p-value compared to the significance level alpha. Alpha is not given, so we would use 0.05. Since 0.14 is less than the significance alpha 0.05, we would reject the null hypothesis. And in the conclusion, we would need to write a statement that makes sense. To write the statement, notice that the initial claim or the original claim includes the equality sign, and we reject the null hypothesis. We then write the statement. There is sufficient evidence to warrant rejection of the claim that the mean concentration in a large shipment conforms to the target level of 250 ppm. We reject this original claim. This means it does not conform to the target level. And again, this is because we reject the null hypothesis, and the null hypothesis states that mu equal to 50, but we reject it.